Good afternoon, everyone. I'm Christina Dali from the Department of ECE. In this lecture series, we are going to discuss about the bandwidth efficiency. So what is the purpose of the bandwidth efficiency mean? We have to maximize the data transmission. So why we are going for this bandwidth efficiency means it is used to measure the network performance and the capacity. Suppose if we are using the limited spectrum availability, how it enables faster data rate related to that of the modern digital communication, and it is also related to that of the mobile networks. So it is one of the parameter in order to perform the network performance and the capacity. What does bandwidth efficiency means? Suppose if we are allocated a spectrum, we have to check how the spectrum is utilized. So we have to quantify that network, how it is related with the bandwidth as well as the data rate. Suppose if we want to signify some of the spectrum that has been allocated and it has been utilized means we have to see how much of the data has been transmitted within the frequency range. Suppose if we are allocating some of the limited frequency range, we have to check how the utilization of the spectrum has been involved. So we are using some of the formulas and the metrics. So what is the core formula here we are using for this bandwidth efficiency is the data rate and the bandwidth. The data rate we are going to measure in bits per second and bandwidth we are going to measure in the hertz. So here we are going for one of the error correction techniques, which is nothing but the forward error correction. So why we are going for this forward error correction means in order to avoid the noise and the interference. So if we want to calculate the efficiency, we have to check the data rate and the bandwidth. So this is the formula in order to find the efficiency. Here we are having some of the factors that has been affected. So what are all the factors that has been affected means modulation schemes, the adaptive techniques, the channel conditions, and what are all the FEC overheads. For example, if we want to add the redundancy, we have to improve the reliability and we have to consume a portion of the available bandwidth. So here the channel conditions what we are using means the noise and the interference levels. So the noise and interference levels in the communication channel will degrade the overall efficiency. And the adaptive techniques means we have to optimize the performance parameters. So these are all the factors that has been affected the bandwidth efficiency. The next one, the modulation and the coding schemes. So here we are using different modulation schemes. The different modulation schemes is based on the real-time channel quality. So here we may use 256 or 1024, whatever it may be, but we have to require the higher signal to noise ratio for the reliable transmission. So this balances the capacity as well as the reliability process. The practical improvements in the networks, the first one is the dynamic network issues. It is mainly used for the intelligent routing and the traffic management. The next one is the microwave links. Microwave links already we know that there will be a wider channels and the more higher modulation orders. That has been delivered the capacity gains. The next one is the compression and the optimization. It will reduce the overall amount and it will lower the bandwidth requirements. These are the improvements we are using. The next one is the measuring and enhancing efficiency. How, what are all the measurements we are going for? This is one with is bandwidth in hertz, the data rate, another one is symmetrical versus asymmetrical. The enhancement techniques we are using in order to combine the multiple network connections, the payload compression to reduce the data size, and the adaptive modulation for the dynamic optimization. These are all the real world examples where we are using in the data center networks, microwave systems, and long terminating equipment in the. Thank you.